Okay, so now we're going to kind of go backwards from what we've been doing. So we're going to write the quadratic equation whose roots are -5 and 5 and whose leading coefficient is 5. So we want to go back and kind of undo what we've done because we're going backwards. Now I know that x equals -5 and x equals 5. They're telling me that those two pieces equal are my roots. So remember, if I added 5 back to both sides, we're kind of undoing this. I'd have x plus 5 equals 0. Well, there's one of my roots. And then I'd go -5 minus 5. X minus 5 equals 0. There's another one of my roots. So when I'm given my roots, now I ended up with -5 and +5 in here, but remember it's kind of backwards. So this -5 actually turned into a +5 because I had to undo the addition here, or the subtraction. And the +5 turned into a -5. Because they're both 5s, really not going to change much here. So we'd multiply these back together, because remember that's kind of, we're going backwards, so they equal 0. We do have to deal with this leading coefficient of 5. So we have to put this on here. We can't just leave that alone. That has to be put back on there. And now what we need to do is multiply this out, because I don't think, let's go ahead and try it. I don't think they're going to accept it this way. I think they're going to want us to simplify it. I'm going to go ahead and try just to see what they do. Why not? Let's see, because this isn't really finished, but they might accept it. Ooh, it accepted it. Look at that. So this is the quadratic form, or a quadratic equation with these roots and this leading coefficient. So that's perfectly fine. But we, in order to make it look, the way that we're used to making it look, we would want to multiply these out. And this is a difference of squares. If we notice, it's x plus 5, x minus 5. So this would end up with x squared minus 25. That's what these two would be. And then we'd multiply by 5 again, like this, and we'd have 5x squared minus 125 equals 0. This would have also worked if we solved it and worked it out this way. And I know when I did it in class, that's a little bit more what I pushed toward, because that's, I think, what they're going to have us do on number 10 here when we move forward, if I remember correctly. So let's go ahead and go to the next one. Okay. So write a quadratic function f whose zeros are 13 and -2. So remember, that means that I had x equals 13 and x equals -2. And it's f of x, so I know they want me to use x as my variable. That's how I knew that was an x. So I have minus 13. I want to make them equal 0 again. So x minus 13 equals 0 plus 2 plus 2. So these guys cancel. X plus 2 equals 0. So here are my two factors. So if you notice, 13 turned into -13. -2 turns into +2 when I put it back into the formula. So I'd have x minus 13 times x plus 2 equals 0. I don't know. I'm going to try it again. Let's see if they'll accept it this way. Kind of an interesting thing if they accept it this way, factored and all. Just like this. Let's see if they accept that. Ooh, it accepted it again. So these are just the factors, but again, I could go through and I could do my FOIL. And I tend not to necessarily follow FOIL. It's kind of the same idea, but what I do is I follow the first one. So I go x times x, and that's x squared, and then I go x times the second piece, so that's plus 2x. And then I take this next one, and I guess I'll do that in green. I go -13 times x, and that's -13x. And then -13 times 2, and that's -26. And then I combine like terms, which should be they should be in the middle, just like FOIL. So I end up with x squared minus, this would be a minus because it's 2 minus 13, so that's 11x minus 26. So again, that would have also been correct. if I worked it all the way out to actually see the quadratic instead of the factored pieces.